this project is about building a NIRD, or a National Infrastructure Resilience Demonstrator. And as in the introduction we said, this National Infrastructure Commission was referenced. So the motivation for this project comes from actually a work that was done with the National Infrastructure Commission. And this report, as Brian had already introduced previously, made a recommendation that regulators should build some sort of system to stress test your energy, transport, water, digital systems. And while this recommendation was made, there was a gap that was identified that, well, it's very difficult to do it, essentially, because there's a lack of understanding of this interdependence, infrastructure interdependence. And what that lack of data leads to is a lack of coherent risk metrics and modeling capabilities. So the history of our work comes from a project, as was also kind of referenced previously, called the ITRC Mistral project, which was a £10 million EPSRC funded initiative over almost a decade. And as DAFNI, Brian was talking about, is all about legacy. So some of that legacy sits in DAFNI. And ITRC has been working with DAFNI for a number of years, developing interdependent infrastructure models. And mostly the work that is on DAFNI is on high-level models which have been used for long-term infrastructure planning and coming up with long-term scenarios of infrastructure growth under socioeconomic indicators and climate change. And a lot of this work has been published in peer-reviewed journals and everywhere, and in policy reports. What has also happened within our ITRC project is, in a parallel stream, there's been a development of a national infrastructure database of spatial infrastructure networks. So what you see over here is, from left to right, is a representation of electricity networks all the way from the generation, the power plants, all the way to the distribution and to the customer. Then there's a representation of the telecoms networks, water supply system, railways and roads that we have developed over the years, and we've collected a lot of data. And this data set, over here, I've kind of shown it in a bit of a siloed way of each sector just for representation, but we've also kind of built interdependent linkages between these networks over the number of years and collected a lot of data information on that. And what has happened is that this data we used in this background study that informed the National Infrastructure National Commission's resilience report in 2020, and our background report, which is publicly available. For example, we did some stress testing for the National Infrastructure Commission. And what you see over in the Sankey diagram is like we simulated some close to kind of 18,000 scenarios of failure of the electricity network and capture their cascading effects, like failures that go from the electricity network towards other networks. And we found that 60% of those failures, the stress testing, they kind of cascaded further to telecoms network. And then there was also this feedback back to the electricity network and so on and so forth. So this captures these kind of whole chain of events which are not just first order, but second order, third order, fourth order, so on and so forth, till kind of your failure across multiple interdependent systems stabilizes. One of the experiments we also did for this study was just looking at, like, if suppose we improve interdependent linkages between networks and add one more linkage between different networks, some of these failures from 60% cascades just reduced to 5% of failure events only cascading. So this was kind of an interesting study. So our work in this project, in the NIRD project, builds on, first of all, this data that we collected and compiled. And we want to now integrate this with some stress testing of actual hazard events, like extreme storms and floods. And we, of course, want to further develop this interdependent network failure cascade model, for which we already have data and capability, and we want to test more realistic resilience options as well. So what is the outcome over here is, at the end of this project, we will have a national scale modeling capability and a bunch of software tools on DAFNI in order to quantify risk and resilience of UK infrastructure networks in a spatial way. So the vision of our project on the DAFNI platform is somewhat laid out over here. We're already working and are in discussions with JBA, with whom we have worked with in a number of years, to have some 2 or 3 flood and storm event sets. And my colleague Fred over here is working on developing extreme storm event sets as well. And then our database that we have compiled, we want to further enhance it of national infrastructure networks and integrate building and population data sets as well, new versions which have come out through census and other ordnance survey and other data sets. And all of this sits on the DAFNI platform. And what is the outcome of this? Since this is a demonstrator, the main outcomes are some sort of kind of code base in Python. Everybody talks about Jupyter notebooks in Python. We do that a lot. So we want to kind of have this hazard network intersection modeling and a bit of capability that a network flow disruption analysis can be done. And it's all about capturing cascading effects and systemic effects and metrics of loss and damage, essentially, or risk metrics, quantifying population disrupted, economic losses, and then coming up with resilience options which could be tested. And all of this code base will kind of, our hope is allow flexibility of people to kind of look at this data and also kind of introduce some of their resilience options testing as well. Again, we already have a GitHub and a lot of development within the GitHub. But again, like as Richard was saying, a lot of the GitHub needs to be kind of further cleaned and everything, which is what we'll do in this project. And we want to come out with a user manual, which and a data specification and how to work with our data and maybe even enhance and introduce some more data set. And also create some sample visualizations, which I guess the DAFNI platform already has a lot of capabilities. So we will leverage on that as well. This is kind of our timeline of this project, and I've kind of just shown 3 kind of red boxes, which is part of like in this project, we want to do a lot of stakeholder engagements at different kind of points of time. So sometime kind of in December, we would like to kind of have some stakeholder engagement, and again, sometimes the next year. And yeah, I invite people over here today in the room who are listening to this presentation. Please reach out to us. And we would like to kind of engage in what kind of you want to see from a national infrastructure resilience demonstrator within the scope of what I've spoken. And our team is, I'm the PI, Professor Jim Hall, probably most of you know him. Tom Russell, who's a DAFNI champion, I've been told it's a big thing, and he kind of has a lot of experience working with DAFNI right from day one since these models and tools were developed. And yeah, Fred, as I said, and other team members are here as well. And yeah, thank you very much. Here's my contacts. Please reach out to me.